Hi, geometry students. We are moving on to sections 4.4 and 4.5. We're doing this all as one big group. Notice the section is called Proving Congruence, and it's got all of these letters, SSS, SAS, ASA, and AAS. So instead of in section 4.3, we listed all the corresponding parts, and then we wrote the congruence statement in which the order matters. We can kind of use some shortcuts. So we don't have to list every pair of sides and every pair of angles. So we'll be dealing with all triangles. And first of all, let's talk about side, side, side congruence. You might be shocked to learn that that's SSS because we're a little lazy. We don't like to have to write out all of that. Side, side, side congruence says, if three sides of one triangle have a corresponding or congruent part to three sides of another, then the triangles are congruent. We don't have to worry about the angles. We just notice that all three pairs of angles are congruent. So even though my triangles don't look fabulously congruent, notice AB is congruent to ZX, BC and XY, and AC and ZY. Therefore, we can say that those triangles are congruent. We could do a congruence statement of triangle ABC is corresponding to, and how would you name the other triangle then? Remember, this is important. The order in which you name it is important. So even though we're using all three pairs of sides, we're going to be able to figure out which angles are corresponding. It looks to me like it's going to be triangle ZXY. Double check me and let me know if I'm right or wrong. So there's our first way of kind of taking a shortcut to saying that triangles are congruent. Then we've got side, angle, side. First of all, let's mention the included angle. An included angle is an angle formed by two adjacent sides of a triangle. So notice in this diagram, angle D is formed by the sides with the congruent dashes, FD and ED. Angle B is formed by the two adjacent sides that make up that angle, AB and CB. So it has to be an included angle. So if we're talking about side angle, side congruence, SAS, because we're lazy, it says this. It's a little long, sorry. If two pairs of sides and an included angles are congruent, then the triangles are congruent. So it has to be the included angle. That's why I mentioned that before we even got started. So side FD and AB are congruent. ED and CB are congruent. And then the angles in between those, the included angles, are congruent. So we could say that triangle FDE is congruent to, remember, be careful on your congruence statement. It looks like it's going to have to be ABC. I really need to switch it up and name it in a weird order. FDE and ABC are congruent triangles. So that's side, angle, side. So basically what we're going to do in this section is I'm going to say, here's two triangles with different things marked. What would be the way that we would know they're congruent? Is it side, side, side? Is it side, angle, side? Or is it the other two types of congruence we can use? So I know that this triangle is not in your notes, but I want to talk, we just talked about an included angle. So I wanted to mention an included side. It's a side located between two adjacent angles of a triangle. So in other words, if I had a triangle, let's say I have another one down here just so that you can see. If I've got angle A marked with this angle down here, angle B marked with this one down here, what would be the included side on that top triangle? Remember, it's got to be side located in between them. So it would have to be side AB. It would have to be this side right here, right in between them. So it's got to look right in the middle, just like that angle was right in the middle of the two sides for side, angle, side, or the included angle. I know that wasn't in your notes, but I want to make sure that you see that. Notice how the diagram looks. So angle, side, angle is what that leads us into. Angle, side, angle says this. If two pairs of angles and the included sides are congruent, then the triangles are congruent. Two pairs of angles and the included sides. So again, all that terminology, we used included angles in the last one, included sides here. So notice angle T and angle G are congruent. Angle R is congruent to C. And notice how we've got an included side. Side TR is right in between angles T and R. Side CG is right in between angles C and G. So these two triangles are congruent because of angle, side, angle. Notice how if you read it, it looks like an angle, a side, and an angle. Angle, a side, and an angle. So it goes right in order exactly how we said it. ASA, angle, side, angle. So I could say from that top triangle that triangle TWR is congruent to the other triangle because of angle, side, angle. How am I going to name the second triangle if I name the first one TWR? Hopefully you see without even needing to really think about it, it's going to have to be GHC. So we're doing lots of practice with writing congruent statements. It is kind of a big deal. Remember, if I give you the congruent statement, I don't even have to tell you or give you a diagram because you automatically know what's corresponding. Even if we don't know, like we know in this diagram, H is in the middle, so it has to be congruent to W because it's in the middle, even though they're not marked on our diagram. Last but not least, we've got one more way to show that triangles are congruent without having to write out all the pairs of sides and angles. This one is angle, angle, side. So you might be shocked to learn that I just write AAS. By the way, we do not do angle, side, side. That is not one of our things, so don't even think about it. Angle, angle, side says if two pairs of angles and a pair of non-included sides are congruent, then the triangles are congruent. So non-included sides are the ones that are not in between them. They're off to a side, one side or the other. So notice I've got two pairs of angles. Angle K is congruent to angle A. Angle L and B are congruent. And then the side that is not in between them, off to a side, it could be two really. So then this KJ and AC, the included side would be KL and side AB, which would make it angle, side, angle. So just be careful on those. Those are a little bit tricky, whether it's the included side or the non-included side. So since I know that I've got two pairs of angles and that non-included side, I can say these triangles are congruent. So I would name the first one triangle, let's name it KJL, just for something tricky. Triangle KJL. And what would triangle KJL be congruent to? How would you name the other one? Triangle ACB, right? Hopefully you've got this all down and it's super easy for you to write that congruent statement. All right. So here's what kind of problems I'm going to give you. I'm going to tell you, determine which pairs of triangles can be proved congruent. I just gave you two options on this one. I didn't want to throw all four of them. So either using side angle side or side side side, write a congruent statement. Here's the thing, there's something sneaky from section 4.3 that we haven't done yet, and so I want to make sure I mention this. Notice how in example 1A, we know that side RS and TS are congruent, right? They're marked with a single dash. We know that side UR and UT are congruent, right? Because they're marked with a double dash. I'm not sure if you remember that reflexive property from section 4.3 that said anything is equal to itself. I think we did triangle ABC is congruent to ABC in the notes. Reflexive, anything is congruent to itself. So in order to say if this 1A is side angle side or side side side, I only have two pieces. I have to have all three pairs of angles congruent or two pairs of angles with the, two pairs of sides with the included angle. I think I said the first one wrong. All three pairs of sides congruent. I don't know anything about angles in this first diagram. All I know is two pairs of sides, but wouldn't you agree that side US is a side on the top triangle and side US is a side on the bottom triangle, right? So I can sneakily mark US with triple dashes. It doesn't line up with anything else with triple dashes because it's the same thing. US is congruent to US, right? It just happens that one of the sides US is on the top triangle, one of the sides US is on the bottom triangle. I now have three pairs of sides, so I can say side, side, side for this. And I would probably also say triangle RUS is congruent to, how would you name the other triangle if I name the first one RUS? Looks like probably TUS. So letter B is similar. Notice, well, sort of similar as far as the reflexive. Notice I've got a pair of congruent sides. I've got that reflexive side PL is PL. I've got triple dashes on that. The first PL happens to be for the top triangle. The second PL happens to be for the bottom triangle, right? It is the same side. It's the same length because it is the same on both triangles. Now, do I have another pair of sides or do I have another pair of angles? Everybody knows back from chapter whatever it was, 1 or 3 something, that every right angle is congruent to itself, right? So that angle at P, right angle at P, has to be congruent to that right angle at P. 90 degrees equals 90 degrees. So would these two triangles be congruent because of side angle side or side side side? And is the angle the included angle? Is it where the two congruent marked sides touch? It sure is, right? Both of the legs on those two right triangles. So these two triangles would be congruent because of side angle side. If I name the first one NLP, how would you name the second one? Looks like MLP. I want to make sure we talk about C and D. We don't need to talk about everything, but I want to make sure I mention these ones because we need to make sure that you see what it is that we're looking for. Because remember how old stuff keeps coming around, right? In letter C, I've got a pair of single dash sides. I've got a pair of double dash sides. So do I have another pair of sides or do I have some angles that are congruent? Well, I don't know if QR and TU are congruent. There's nothing telling me that they are. However, we're really going to flip back to chapter 1. Think about vertical angles, right? This angle at S is a vertical angle to this angle at S. Those guys have to be congruent to each other. Those angles at S are the included angles between the sides that are marked. So this would be side angle side. And that means if I name the first one, be careful on this one, I'm going to name the first one QSR is congruent to. How are you going to name the second one? Hopefully you're not going for the U for the first letter because it looks like it's got to be T corresponding with Q because it's along the it's along the double dashed line. So I'm going to have to call this one TSU. Got ourselves a side angle side. Let's skip D. I do want to make sure I mention D. You probably will need that reflexive property because DU from the left triangle is congruent to DU from the right triangle. Therefore, it looks to me like side, side, side. I don't know about you. All right, so a couple more then. Determine which pair of triangles can be proved congruent by either angle, angle, side, or angle, side, angle. Write a congruence statement. So in letter A, hopefully you're flipping back, thinking to example C just now. Notice I've got JK is congruent to KM. I've got, simple to see, right, angle N and angle L. And what else do I have that's congruent? Do I have a pair of sides? Do I have a pair of angles? I don't see anything else with sides. It has to spell it out to you. However, don't forget about vertical angles. The two angles at K are vertical angles. So I've got two pairs of angles and one pair of sides. Is this going to be angle, angle, side, or angle, side, angle? If I go around the triangles, if I trace around them, or if I look at where that side is the side with the single dash in between the two angles? If it's in between, it has to be in between in the answer. If it's off on one side or the other, it has to be off on one side in angle, angle, side. So this looks to me like an angle, angle, side. If I call it triangle JNK, how are you going to name the second? No, I'm just randomly picking a way to name that, by the way, so there's nothing technical about it. If I call the first one JNK, how are you going to call the second triangle? Be careful. It looks to me like, I should have double dashed these two, by the way, because I already had singles. So J has nothing marked for an angle, so that's going to have to line up with M. The L and the N we know are congruent, and K has to be congruent to itself because they're vertical angles. Letter B is already nicely marked for us. Notice I've got angle B and angle E as congruent. A and D are double arced. And then I've got that side right there. Is that side AB and side ED, are they in between? Are they the included side or are they off to the side? Side. Right? Those are right in the middle. It looks like angle, side, angle. So if I name this triangle BAC, how would you name the second triangle? Looks to me like it's going to have to be EDF. Notice C and F are listed last. Those are the angles with nothing on them. A and D are listed in the middle, and they're both with the double arced. That is what I'm going to ask you to do. So which one of the four methods of saying triangles are congruent can you use? That is it for sections 4.4 and 4.5. Thanks for sticking around. Bring any questions. We'll see you next.